So let's go through the unit final for those of you who are online working at home so that you can send me your corrections and why you think you made the mistakes so that I can have it open again for you to get as a retake on Friday. Friday will be the last day to retake this for the quarter, so just be aware that that's the case. So in question number 1, it says select all the true statements. Well, usually all means there's possibly more than one. So in this case, it says two rhombuses with the same side lengths are always congruent. Number 2 says two squares with the same side lengths are always congruent. Number 3 says two parallelograms with the same side lengths are always congruent. And number 4 says two rectangles with the same side lengths are always congruent. Well, let's think about the image for just a minute. If I draw a square, I will always have 90-degree angles, so those can't change. So squares should always be and are always congruent. So the next one is rhombuses. Well, if I draw a rhombus, I know that the two side lengths have to be equal to two other side lengths, but I know the angles have to be different on the top and the bottom along with the sides. And guess what? If I can squish that, I can make it bigger because the side lengths are always going to change. So that one's not the case. Two parallelograms, well, that just means all four sides are parallel, whether it be the top and bottom are parallel or the two sides are parallel. But no matter what I do, I can always make those angles change. So this one is not a true statement. And rectangles, think about it. Rectangles are always 90-degree corners. Number 2, which of these sequences of transformations would not return to a shape to its original position? In other words, if I used this, took something, moved it back, would it go back to the same place? Well, I know if I rotate 180 degrees, that's halfway around. And then I rotate 140 degrees. Oh, that's only 320. So it's not going to get back to its original position. The next one says translate 1 to the right, then 4 to the left, and then 3 back to the right. Well, I've used 4 to the right and 3 to the left. It got me back where I was. So reflect over the line. Here's a line. I'm here. This is the line P. Reflected here means it's here. Reflected back here. Nothing's changed in its position, so it's back to where it started. The other one says translate 3 units up and 3 units back. So it's just back to the same. Question 3 said, look, Diego made the shape on the left. Elena made the shape on the right. Each shape uses the five triangles. Below, select all that apply. Well, if Diego made this one and Elena made this one, are they different? Or are they exactly the same? Well, if they're not the same, they can't be congruent. But, however, this triangle here is the same as this triangle here. Doesn't mean it's in the same position. It just means it's the same. Elena's design is a translation of Diego. So in other words, did I just take and slide this over? I didn't. I used actually, if I slid it over, this triangle would be in the middle. These would all be moved down. Okay, explain the transformations. Well, in this case, I'm going to look at this point right here and this point right here. Two things have to happen, right? Number 1, I have to get it down here, but I also have to get this part, this point, this vertex up to the top. Well, the only way to change a vertex is to rotate it. So the first thing I need to do is I'm going to have to rotate it some degree. In this case, it's 90, but other cases it may not be 90, but it doesn't really matter. And then I would have to translate it down and to the right. Number 5, for each pair of shapes, decide whether or not the shape A is congruent to shape B. Okay, so let's look closely at these. Let's look at the second pair. And believe me, I have a bunch of different questions in here, so they're not going to always see the same things. Well, first thing I'm going to look at is the angle. Look at that angle. Look how small it is. Look how big this one is. So this one is not congruent. So this one must be congruent. Well, now I have to think about how my rigid transformations, how I can take this one to this one. Well, it looks like This is up on the top, so if I turn it this way, I don't know how far, it doesn't matter. But if I do a rotation and then I slide it over, that will be on top of it. So pair number 1 is the congruent one. Now, if you took this question, if for some reason you got, these look really, really close. However, if you use patty paper and put it on top of the other one, you would actually see they're not congruent. So the second pair, oh, this is kind of like that other one up the top where I've got a point here and a point here. Well, that means I already know this is the one that I need. So the second pair, I just now have to describe what I'd have to do to put it on top of A. Well, with this angle pointing down, this angle pointing up, first thing I'm going to have to do is I could reflect this and then move it over. Is that a possibility? It's a possibility. What if I rotated it? Let's see, if I spun this around, then this would be up on top. And actually, this is not in the same position. This would be on this side. So I'd have a point over here. So this is actually a reflection and move it over. So you just have to describe what it is how you're getting there. And it doesn't matter how you get there. Okay, so we're going to use alternate interior angles, vertical angles, the things we've talked about. So all I have to do is really fill in all the information. FAB, so this angle here is the one I'm looking for. Well, that angle right there is an alternate interior angle to here. So if I filled in this with supplementary angles, I'd find out that it was something like 23 degrees. And then this becomes the same as this. So my angle here is 23 degrees. Then my angle AFB means this angle right here is going to be the same as this angle here. So I already know this is 23. So now I'm going to just use the angles in a triangle. 42 plus 53. 42 plus 23 is 42 plus 23 is 65. So this means this one is 115, which means guess what? This one's exactly the same, so 115. Now I know everything that I need. I've got 23 here, 115 here. I just now need to go here to here. Well, guess what? Alternate interior inside the parallel lines means interior. Alternate means it's on the opposite side of the line. So this angle, exactly the same as that angle. These are a little bit different, but the first thing you have to think about is they are rotated. All started with this triangle. This triangle rotated here, so that means B is here, C and A are the same, and A down here is C up here. Same thing happens here. I rotate, I spin it, so that means A is here, B is here, and this becomes C. So now I just have to compare them. Well, there's a couple of ways we could compare them. DCA could be congruent to CEB simply by a translation, because we already know they're identical. So that's one possibility. I could say ACB is the same as BCE. Key to this one is, remember, you always have to have the angle in the middle. The actual angle is in the middle of your letters. So in this case, A, where it starts, C, where the angle is, B, where the angle stops. This one's a little bit more difficult, but the one thing we have to remember about squares, inside a square or a parallelogram, any four-sided quadrilateral, the angles will always add up to 360 degrees. So that's the measurement of this angle, the measurement of this angle, the measurement of this angle, and the measurement of this angle. How does that happen? Well, because these are all the same triangle because of the translations, that means that this angle plus this angle have to be the same as this angle plus this angle. Therefore, we don't have to have this angle. but we know that this is some measurement. We don't know what it is, and it doesn't matter. This is some measurement. We don't know what it is, and it doesn't matter. But these two angles are exactly the same. And when all four of my angles, I add them up, I get 360 degrees. So this is the last one. Probably one of the most confusing. It says CDA is the image of ABC after 180 degree rotation around segment AC. ECB is the image of ABC after 180 degree rotation over midpoint of segment BC. It says, explain why ABCD, ABCD, and ABEC are parallelograms. We know that a parallelogram has two sets of parallel lines, but that's not what the question is asking. The question's asking, how did they become parallel? Well, when I rotate around a midpoint to a triangle that's the same, it creates parallel lines. Therefore, this one becomes a parallelogram. Same thing here. If I rotate this around a point off the line, it also becomes a parallelogram. Okay, so now I've gone through them all. You probably won't remember them, but that's okay. I just need you to go through, correct the questions you have, send me a PDF or send me a picture of what you did, and I will give you the password to retake this assessment.